Let's take a look at the vector of this system. We have a balanced power here, we have a balanced load. As you see here, we have a three-phase voltage and a three-phase current. We have a balanced system, and similarly we have a balanced setup here. As you see here, we have a current and voltages on a balanced sheet. We have a PWM here, PWM waveform, which is basically a balanced system here, as you see. And coming back to the power analyzer, you could see here the measurements. We have the voltage mean. As you know, the drive, you have to employ a mean method of voltage calculation because it's a PWM. And we have a RMS current. We have a power that is about 35 watts for each phase, and power factor, like you see. I am running this at a very high speed, which is about 150, 152 hertz, and you could vary this at yeah. So I am leaving it at 100 hertz. So you have a certain voltage and certain power here, and we can take a look at the voltages of each and every segment. We have a current of each and every segment, and we have a power of each and every segment. Now, similar to what we see here, we could also get a waveform segment here. You look at this, yeah. You look into this waveform, you could get a waveform as well as a value of this. We could ensure that you could see the voltage PWM and the current and the values as well. We go back to the DC systems now. This is as far as the AC. Now the DC systems, we could see that the input to the drive is 23 volts. The current is about 3 amps at this particular RPM, and the power is about 0.86 watts, and this is a power factor, as you see here. And yeah. Similarly, you have a current system here. You look at the harmonics of this system. You have a harmonics graph. So you have quite a big harmonics at level that is. Let's take it the fundamental of. So this is your harmonics. This is the motor harmonics, the voltage harmonics, the current harmonics, and the power harmonics. So this is the percentage of fundamental, and we have a level harmonics to give you what is the current harmonics. As you see, the harmonics differ according to how you look at it. We also have FFT on it. So this is your voltage FFT and the current FFT. What you could do is we could do a proper study of this FFT using the recorder. And in the meanwhile, let me show you the statistics of the motor. Here we have torque about 398 millinewton meter, and you have here speed. It's about 3000 RPM. You could vary the speed. So depending on the speed, you could vary it. And this is the motor power here. It's about 1.127 kilowatt, and the motor has a kind of a very least slip. So let us load this motor now, and you can see that there is a difference in slip. As and when the motor loads, you could see it slips up. As you can see this, so this slip can be recorded. So there is a huge amount of slip and vary in the speed of the motor, and this is good in analyzing these patterns. And just to see, now going back to the recorder here, we could probably take a look at how this records over a period of time. And let me show you this. As you see here, can you see the current that comes up? So similarly, we could have this entire waveform, as you see here. So this you could stop and then analyze the inrush current every time the motor loads up, and this is a good tool for you to look at the PWM. So we have the entire pattern here of inrush, and this is your voltage and this is your current. You can employ a zoom and then see how the current and the voltage has occurred over a period of time. You could move this in a different location to see how inrush happens. As you can see, there is a huge amount of inrush as you move forward, and once you move away from it, you get the current drops down to a normal level. So here you can see there is a current that is swelling here up to this point, and then it drops down, and you have a detailed study on the same. This is one particular event. So similar events can be seen event by event. So next segment we'll look at how we look at the efficiency of this system. Thank you.